Coming up on This Week in Radio Tech, Michael Patton joins us to talk about figuring out how to keep a transmitter going longer than maybe it should. What do you do to keep a transmitter operating at peak efficiency? What conditions in the transmitter building can cause a transmitter an early demise? And when is it time to just say enough is enough? Out the door you go. Mike Patton's coming up, joins Chris Tobin and me on This Week in Radio Tech. Our show is brought to you by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. By the new Telos VX Prime. VX Prime is the affordable multi-studio talk show and on-air phone system for smaller facilities. And by Axia Livewire Plus. Livewire Plus includes fully compliant AES-67 audio over IP built in. Livewire convenience plus worldwide connectivity. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack. Glad you're here. This is the show where we talk about, engineering, audio engineering, radio engineering, everything audio, RF, digital stuff, streaming now. And we've got a guest today who I've been just delighted to have on the show once before. We're going to have him on again today to talk about CPR or RX, prescriptions for old transmitters, and how to make decisions about that and how to bring things back to life and how to make judgment calls about that. It's Mike Patton. We'll get to Mike in just a minute. I want to bring in, if he's ready, if he's there, my co-host. It's Chris Tobin. Chris, welcome in. Glad you're here, buddy.
Oh, thanks, Kirk. I'm doing well. And since we're talking about health and care for transmitters and things of that sort, I'm actually in a hospital room right now, Mount Sinai in New York City. I'm in out of the rain, believe it or not.
Yeah, indeed. Remember last week you had a family member in the hospital. Are things generally going okay?
Yeah, that's why I'm in this room. I figured I'd try and do two things at once. It's working out very well, actually.
Well, I appreciate you being there, and if you can give our kindest regards to your family, please do. Please do.
I will. I just gotta, you gotta keep the breathing going, and this is one of these devices. You gotta check your lungs.
Oh wow!
Yeah, look at that.
So it's like a volume indicator.
Yeah,
volume of air.
The idea is to get the lungs expanding after surgery. So that's the plan.
Wow. Okay. All right. Well, glad you're here. Anything exciting to report on your end? I heard it just rained, so you're not outside anymore. You had to zoom inside to the hospital.
Oh my goodness! It was one of the best storm cells I could say for the season so far. I mean, I'll look out the window and it's clear now, but it was gray clouds, like 3 layers of gray clouds, if you could picture that. Like cloud on top of cloud, and it was so dark that some of the street lights were turning on, and the wind was starting to pick up. And all of a sudden, it just opened up. It was great. Sheets of rain. It was like watching a movie set. It was excellent. And then lightning came. So it was perfect. And then it just left. Just continued east. And just continued east. And now the sun is out. The streets are dry. You would never know that there was a flash flood a moment ago. I'm looking down onto what is this, 3rd Avenue, and there's not even a drop of water. It's like, wow, you'd never know that storm just rolled through.
It's the way weather is, isn't it? And it's interesting how many engineers take an interest in weather. A lot of our viewers know that certainly I have a degree in meteorology from Mississippi State. And I'm not doing the Fox 17 weather thing anymore. The company that owns Fox 17 did away with freelancers. They can only use fully hired employees, and we didn't. That wasn't part of the relationship. So I'm no longer doing weather on a local TV station. But the nice folks at the Weather Channel have had me on about 3 times now to comment on Middle Tennessee weather, and so I was just on last night. So I'm still getting my weather fix.
Excellent.
Jumping on the Weather Channel. But in fact, I'll have a tip, and Mike Patton's listening in. We'll bring him in just a moment. We're going to have, at the end of the show, we tend to do a tip of the week, and I know what my tip is going to be. It's going to be about lightning, because engineers, if they're not interested in weather, they certainly got to be interested in lightning, because we have to deal with the aftermath of lightning in our jobs. Yes. In fact, I'm sure you and Mike Patton will touch on that. So let's bring in this mystery man who's going to tell us about prescriptions for transmitters. Mike Patton from Michael Patton and Associates in Baton Rouge, Louisiana. Hello, Michael. Welcome in. You're on, buddy. Are you there?
Yeah, my audio dropped out for a second, but I'm here.
Yeah, it's okay. Things do that now and then. Glad you're here. Welcome in.
Thank you.
So you've been on the show before talking about, the on-the-ground repairs. I mean, the kind of, getting your hands dirty kinds of things. And that's what we're going to talk about today, but we're going to focus on transmitters, right?
Yes.
Yeah. What brought this to mind is that, I own some stations in Mississippi. I'm part owner, and I own the part that doesn't write the checks. And so we've had a lot of activity at these stations, and Michael and his crew have been just instrumental in taking some not terribly old, but at least, well-worn transmitters and putting them in a new location, fixing them up, make sure they work right. And so far, we've had really good success with those after Michael's put his hands on them. So, Mike, hope you'd be prepared to tell us about that and to give us some of your insights on to help engineers decide, okay, when is it time to retire a transmitter, but when is it time to, if we just give this some elbow grease and the right parts, we can have a perfectly good transmitter here for another couple of years. So that's what I want to hear about if you're prepared to give us your insights.
I am. I very much enjoyed making the transition from being a more traditional contract and project engineer to being essentially a professional transmitter rebuilder. And I enjoy that. I've got a good crew, and we have a nice facility here. And got some war stories that hopefully will be of interest to your listeners, your viewers, and we certainly could talk about experiences, good, bad, and ugly, with various transmitters.
I know a lot of your customers are in small markets, and of course, Chris Tobin's in a big market where, us small market guys, our impression is that, well, those big market guys just get whatever they want, and they don't really have to worry about keeping transmitters going a few years longer. But I'm sure my impression is wrong, so we're going to have Chris tell his side of the story here when we come back from our first break. Our show, This Week in Radio Tech, episode 312, with Mike Patton, is brought to you in part by the folks at Lavo, L-A-W-O, Lavo. Everywhere you go, you find touchscreens. Yeah, there's your smartphone and tablet, of course. Supermarket checkout lines have touchscreens. Laptops are coming with them. And so do the radios in new cars. I mean, we touch those things all the time. Even some airplane cockpits have touchscreens. They make sense because they're simple and natural. If you can touch the thing that you got to touch, and make it do something, that's more natural than touching, soft buttons around the edge of the touchscreen or some knob somewhere else. So the intuitive controls help you finish tasks faster and make fewer errors. If you can just hit what you want to do, no matter what the task is, then that's a better thing. It's time you brought the power of touchscreen to your radio studio as well. You can with the crystal clear virtual radio console from Lavo. It's L-A-W-O, Lavo. Crystal clear gives talent an instantly understandable multi-touch interface, faders, meters, clocks, timers, talkback, and more. All those live in harmony on a single screen, so shows run smoother and they execute better, sound better. Crystal Clear features Lavo's exclusive Auto Mix. That's the hands-free smart mixing algorithm designed for fast-paced multi-mic talk shows. And they have Auto Gain. What you do is you get your new talent in front of the mic. Maybe the mayor's in. Maybe you got a guest in from a rock group, a music group, or just somebody to talk about a subject. Well, you push a button and the preamp calibrates automatically while your guest is speaking into the mic. With so much advanced automation, talent can even dock the mixing controls and use the screen to do some other things, like working with delivery systems or audio editors or phones. Crystal Clear's power plant measures just one rack unit. It's pretty amazing when you think about the staggering amount of DSP on board. Compression, EQ, voice processing, and precision delay, those can all be applied to all of your mic, line, and digital sources. Optional upgrades include redundant power, MADI, and Ravenna with AES-67. And all that power really costs no more than you spend for an ordinary console. Think about buying a new console? Well, don't decide till you check out Crystal Clear from Lavo. You can go to www.lavo.com and read about Crystal Clear. Or in the USA, call Bill Bennett at Lavo USA. Bill's number is 888-810-4468. That's 888-810-4468 if you want to find out more. The future is clear. It's Lavo, Crystal Clear. Thanks, Lavo, for sponsoring This Week in Radio Tech. We appreciate it. All right, it's Kirk Harnack along with Chris Tobin in New York City and Michael Patton, who is with us, and he's going to talk about fixing transmitters. So Michael, I used to do this too, so I've got a little bit of an idea of what you do, and I've even brought transmitters into my office when I had an office in Memphis, Tennessee. We were actually able to finesse. We had three-phase power in the office that I was renting, and so we were able to even fix up three-phase transmitters, grab a dummy load from somebody, and hook it up and really give it a real bath and a washout and a cleanup. So kind of give us some of your insights or experience, or how do you approach transmitters that have seen better days?
Well, the first thing that's important to us is to make the call as to whether this particular transmitter is worth saving or not. It's a triage thing. If somebody calls me and wants me to repair or rebuild a tube type AM transmitter, my answer is going to be, dude, you're barking up the wrong tree. Time to call time of death on that fellow and haul him off to the scrapyard. Maybe we can save a few parts out of it, vacuum variable caps or tube sockets or something like that. But the time has come and gone for just about any tube type AM transmitter that isn't somewhere in place, and maybe even then. If for no other reason than the quality of the tubes available keeps going down and the prices keep going up, and very few manufacturers are around to even support them anymore. On the FM side, there's still a number of tube type transmitters that are viable, but some of the older ones there are really no longer worth fooling with. I wouldn't want to touch anything older than the HT series from Harris. Anything that's a K or an H3, nope, that's just too old. But the solid state AM transmitters, in my opinion, from the earliest ones on, are still very viable units to have. I really like the MW1 still. We sell parts and we repair modules for MW1s on a regular basis. Yeah, in fact, I was just talking to someone last night who had via email who had some questions about an MW1. I shared him some experiences I had, and we have a lot of techniques we've developed for improving the MW1. People love to hate the SX series and love to hate MW1s, but they're both excellent transmitters, in my opinion.
Hey, I want to bring Chris into this question, because one transmitter style that I have very little experience with, is the Continental transmitters that have a Doherty type of amplifier. And to me, that kind of transmitter is really a bit more like an FM transmitter in terms of its design. It uses a couple of big ceramic tubes to achieve that Doherty design to come up with an AM modulation envelope. Mike, I wonder if you would make an exception to your rule about tube AM transmitters for a Doherty design. And then I want to ask Chris, hey, are there still transmitters like that in the New York area, maybe in main or in backup duty? So, Mike, what do you think about that kind of design?
Well, it's interesting you should raise that question, because I believe we will be shortly rebuilding a 25 kilowatt Continental in Atlanta, Georgia. We're discussing that with the station that's there now. They have a Harris DX50 for their main, and they have a 317 Continental for their aux, which is essentially non-functional. And their main went down a couple of months ago, and I walked them through getting it fixed over the phone. But it's like the owners said, maybe it's time to make that aux run again. So yes, I wouldn't object if they bought a newer transmitter and retired the DX50 to being the aux, but I don't think that's going to happen. So I get to rebuild a beautiful shiny 317.
So I agree with you on AM transmitters that are using those 833 tubes. Oh my goodness! I mean, I'm not sure how you can get those. And most of those transmitters that used that style of tube, kilowatt AM transmitters, most of those, the wiring in it is so old. Things are brittle. Things are just break left and right. But Chris Tobin, in your area, you got big 50 kilowatt transmitters everywhere. Are some of them still the Doherty type design?
Sorry for the camera going crazy on me here, but anyway, no. As far as I know, I think everybody's got solid state. There's maybe one or two Harris, the 50 kilowatt AMs still out there.
Oh yeah, the pulse width modulated.
Right.
Yeah.
I mean, I don't know. I haven't taken a tally. Yes, the MW50s. But I know a lot of folks who've migrated over to the Nortel high powered and then have their DX50s as backup too. So, yeah, I don't think we have too many tubes left around in this market. But the Doherty's a great transmitter. I worked on those for years. Those were fun.
And, hey, Mike, why don't you I'm kind of interested in that Doherty design. I only had one that I worked on. It was a 10 kilowatt Continental. And if you've dealt with that 10 kilowatt Continental design, it did not have the oscilloscope on the front panel that the bigger ones did. And so it was more of a set and forget. And frankly, when this was in Memphis, Tennessee, and this has been almost 30 years ago, that we were having a hard time getting the thing to work right. And we had a Continental tech, and if I could remember his name, everybody would know it. He came to Memphis, worked on it, and it's the kind of thing that once it's fixed, you just don't touch it, because it's going to be, nothing's going to drift around, and it's just going to sit there and work, provided a good load, and you don't have to, there's nothing to go tweak on from time to time. Can you remind me how a Doherty transmitter, it's got two big tubes, and one of them is usually off until it needs positive peaks. Is that right?
Yes, they have what they call the carrier tube and the peak tube. The carrier tube runs with no mod and negative mod, and the peak tube only really comes into play when the positive mod goes over about 15 or 20%, if I recall correctly. And the way it does its magic is that there are 90-degree phase shift networks in the grid, on the drive, and on the plate between the two tubes, and there's some interplay with how trigonometry works and the combining the two tubes together as the modulation swings. Basically, it's a huge linear amplifier that allows you to obtain a bit more efficiency under modulation than a conventional linear amplifier would. It's a low-level modulated. The modulator is like exciter is like 100-watt modulated carrier. Else is just a big amp. But the problem is that the unmodulated efficiency is poor. It's like 35% when it's sitting there. And then the best it ever gets under full mod is about 65%. So compared to a modern PDM transmitter or like the digital synthesis like the DX series, which has PA efficiencies in the 90% range, that it's still not any these days. You're basically going to pay the least note on a modern solid-state transmitter with what you're not paying the power company every month by getting rid of a Doherty.
That's a good point. What we're talking. Another reason to get rid of your tube transmitter is that power bill. Doesn't matter if it's an Ampliphase, which was very power hungry, just sit there and burned up power all the time, or a Doherty design, or a pulse width modulator design, probably a little bit more efficient. But yeah. The electric bill, you've probably got, if you've got a big transmitter, you got a big electric bill, and so another reason to go solid state. What about stations in the you're familiar with our stations in Mississippi, and we have one AM that I think now has actually been upped in licensing for about 3.8 kilowatts. It's an odd power level. We were able to go to that, but prior to that, it had always been 1 kilowatt. At the kilowatt level, solid-state transmitters are pretty affordable nowadays, and it doesn't make much sense to pour money into a tube transmitter at a kilowatt. Does it, Mike?
No, not at all. I don't know any. I'm sorry, I do know one station that's still running a tube-type AM transmitter at 1 kilowatt. It's in East Texas. I do the guy's NRSC measurements, and every time I'm by there, it's like, dude, we really could sell you a very nice used solid-state transmitter. And he's like, well, as long as I keep this one running, I'm okay with it. It's like, ooh, okay. But, yes. Actually, you mentioned the 833s earlier. They're not as unobtainium as the 5-500s.
Oh, yeah.
833s are available from China. At 5-500s, once iMac and Amperex both walked away from those, they just got outrageously expensive. And that was almost a decade ago. All the Continental, the Collins 1 kilowatt tube type transmitters used 5-500s, the 820D1, the 820D2. And I remember like maybe 2008, 2007, a set of 4 5-500s was $3,600 when you could buy a brand new 1 kilowatt transmitter solid state for like maybe $8,500, $9,000. And so it's like 2 tube changes, and you're in the same. Hello.
Yeah, go see your banker and make easy monthly payments on something new. Yeah.
Right.
Wow. So I'm a little bit curious, Chris. In a big market like the New York City market, what metric do you guys kind of use, maybe as a rule of thumb, or how do you know you've reached the point where you need to go tell management, we don't need to use this transmitter anymore, or we need to put it in third backup or service, or we need a new transmitter? What fires that decision?
Well, your total cost of ownership in that case would be the electric bill, maintenance repairs, the idea of parts becoming unavailable, things of that sort. But basically, the electric bill. I mean, especially the AMs. I mean, when you do the math and the cost, you're like, wait a minute, it's worth the investment. That's the way to go. And I agree with Mike. Anybody doing tubes these days, unless you can afford the nostalgia, I wouldn't bother. So it's not the cost of energy is too much. I mean,
as a follow up, I'm thinking about some of the tall buildings you have there. Well, Empire State Building and the new Freedom Tower in New York, and I'm sure there are other tall buildings where you have FM transmitters. What do you have to figure into the cost of replacement in dealing with a big building and all the stuff? I mean, you've shown me some of the incredible difficulty and expense that you have to deal with. I mean, I'd almost rather deal with carting a transmitter across a muddy field than deal with all the stuff and getting a new transmitter up to the top of the Empire State Building. A lot of difficulty there. How do you figure that cost in?
Well, they're hard costs. It's just labor costs. It's a known entity. It's a one-time thing. You speak of the Empire State Building or One World Trade Center. I've done work in both. Well, the old Trade Center. I've been on a couple of projects for the new Trade Center, but you just factor it in. And it's just a one-time cost. It's part of the capital project. It's not an expense. That's not operating expense. It's CapEx, and then you're off to the races. I mean, buildings like that support broadcast facilities or multi-site broadcast facility, whether it be here in New York, Chicago, L.A., Boston, even Dallas, they usually provisions are made to be able to get stuff in and out. There is a cost involved, but at least it's done in a way that's efficient, so you can keep the numbers where they should be. It'd probably cost you more to get a transmitter across the swamp than it would to the Empire State Building.
So I guess you're right. These guys are used to that. There's drayage or other companies that move these kind of things, and they're used to dealing in the. See, to me, it's a foreign environment. It just seems so complex. And
absolutely, it is complex.
Yeah.
Yeah, well, the other thing, too, is you got to remember it's part of your lease. So part of the lease arrangements you do, hopefully you do it right, is getting in and out of the building off period and, certain rates that you get discounted because you're a tenant in the building. If you're not a tenant and you're moving stuff in and out, I can assure you will pay the premium price.
So let's check with Mike then. Mike, you're probably not putting transmitters or moving ones into places that are, 100 stories high like the Empire State Building, but you got some challenges as well getting transmitters into some of the funky locations where you have to work in.
Yes, that's true. In fact, in the next few weeks, we're putting a transmitter in an elevated building in the Delta, in fact, not for your stations, but for another of our clients there. And we've arranged to rent a four-wheel drive forklift, which the trade name for the very popular one is called a SkyTrack. And very capable. You can put anything on it and basically drive it of quicksand, and it'll get it where you want it. But it takes a lot of skill to run it, and what we usually do is we hire a local firm in that business, a contractor, and they provide us the forklift and the operator, and that way if they screw it up, it's on their liability insurance and not ours. But it's entirely feasible to move just about anything anywhere. We don't, we deal with stuff that's lightweight usually. So if we have a 2,000 or 3,000 pound transmitter, it's, oh my God, how are we going to move this fella? But these are people who routinely move, things that weigh 10 and 20 tons, chillers and highway equipment and things of that nature. So if you call them up and tell them, hey, I got a 1.5 ton transmitter, it's this big and we need to move it from point A to point B, they say, okay, when you want our crew there? That's their business.
That was one of my difficulties in being a contract engineer. I didn't have enough visibility into, or wasn't smart enough to hire people who were good at that sort of thing to do it. I always agreed to do it myself, and what a dumb mistake. If you're a contract engineer or an employed engineer out there and you're thinking, and your boss wants you to move this transmitter here or there, you got to move something in or out, my goodness, don't do that kind of stuff yourself. Hire professionals. No. So even professionals like Mike Patton, you don't do that yourself. You hire the people that do that.
Exactly right. Now we'll do some light electrical system work and things of that nature because it's conduit and fittings, and that's not very complicated. But if someone wants us to install a transmitter site and we got to bend a bunch of conduit and things like that, no, we're going to sub that out and we're just going to build that into the cost. And if that's something that you want to beat us over the head to do, then you probably should hire another firm because someone in my position, you like you say, you can't do everything. And I think that is a mistake that many is that they want to tell their clients, "Oh, I can do that for very little money, and I can handle all aspects of it," and that's not smart. We're professionals, but we're also contractors. We run under fixed operating costs. My insurance is a significant factor every month. My payroll is my largest expense every month, and I have to make sure that I don't harm my people. I have to make sure that I don't ask people to do something that they're not safe doing, that they're not comfortable doing, or they're going to resent me for asking them to do. And so I have a contractor's license in the state of Louisiana, and I consider myself a contractor, and a contractor has subs. No contractor does all the work himself. Why should we be any different?
Good point. Good point. And I wish I'd learned that lesson a long time ago because I moved too many transmitters. Luckily, I never got hurt. Never, drop one on my leg and broke an ankle or anything like that. I'd usually end up slicing my finger putting connectors on half-inch coax, but I never got hurt doing a transmitter, but I sure could have. Hey, you're watching This Week in Radio Tech, episode 312. Mike Patton is our guest. Chris Tobin is along with me as usual. We're talking about reviving old transmitters and just transmitters in general. When we come back from this break, I'm going to be talking to Mike Patton more about what are some of the common, the most common repairs that he sees. What are the most common causes for transmitter problems, and what does he recommend his clients do to avoid these most common avoidable problems? So we'll have that coming up in just a few minutes. Our show is brought to you in part by the folks at Telos and a brand new product. It's actually a new version of an older product. It's the Telos VX Prime. Now, don't tune out if you're a smaller broadcaster with maybe just 2 or 3 or 4 studios, because we know that the Telos VX multi-studio phone system is perfect for big broadcasters, the big city guys or stations that have a bunch of studios. The Telos VX, which has been out now for, 5-6 years, it's a great phone system for handling lots of lines and lots of studios. But let's say you're a station like mine or like a lot of Mike Patton's clients. You might have 2, 3, 4, maybe 5 studios in your facility, plus a production room or 2. And you want a phone system. You want to start taking advantage of the lower cost of this new technology called Voice over IP, also called SIP, which is the name of Session Initiation Protocol. SIP, VoIP, kind of interchangeable words there for our purposes. And you're looking at, how do we do this? How do we, instead of replacing a phone system in Studio A and then 2 years from now replace the one in Studio B, we're still paying a lot of money for POTS lines or maybe a T1 coming in, we break out to POTS. How do we do that? Well, Telos now has the new VX Prime. It's a lower cost version of the Telos VX, and it really starts to make financial sense for stations with 2 to 4 studios and a production room and maybe a newsroom to get into being able to save money every month on voice over IP lines. Now, let's talk about that money savings. A lot of stations are paying anywhere from $55 or $60 up to $90 per month per POTS phone line. I mean, the phone company kind of has you over a barrel there. You want POTS service, and especially if you've been dealing with a choke line in a market for all these years, you want to try to get that converted over to POTS. To SIP and VoIP. There are a lot of different ways to get SIP and VoIP, and I've even produced a video about that. It's on the Telos Alliance YouTube channel to help you understand, what does it take to get these lines in. There's 5 different ways to get SIP VoIP service into a Telos VX or VX Prime system. So I won't go through them all here, but you can watch that video and either get it from your PBX. You can convert POTS over to SIP. No, that doesn't really save any money. You're still paying for the POTS. You can use a provider that will actually bring new copper or new fiber into your building and give you lines that way. Or you can use an internet-based SIP VoIP provider. That's what a lot of stations do. You need to make sure you have good internet So you may have to bump up a few dollars what you're paying for internet, but hey, you're going to use that for a lot of other functions around your broadcast facility. Bring in your phone lines that way as well. And now you've got phone lines that literally can cost as low as a couple dollars a month. Now, you have to do a little clever work to get to that point, but you can easily get SIP VoIP lines $10 to $20 per line per month, and you can get that cost down in the $2 range if you're go to a little extra effort about it. That's what we're doing. And then now you've just saved yourself hundreds, maybe even $1,000 a month on your phone bill for your studio lines. You can take that that money and easily apply that to a new broadcast phone system. And guess what? It's going to sound better than your POTS lines ever did. With the new Telos VX Prime system, you can even get HD voice going there. Add a PBX. Maybe it's in the cloud. Maybe it's at your facility. And then you can have smartphone apps. You know, your smartphone, you can put a soft phone app on there that's G722. So your employees, when they call in with a report, a traffic report, a news interview, sports scores, they're going to be in 7 kilohertz of audio quality instead of 3.5 or 3 kilohertz of audio quality. So a lot of differences, a lot of benefits that you get when you move over to SIP and VoIP. And the Telos VX Prime makes that possible. We got some videos on our YouTube channel. And if you go to telosalliance.com, click on Telos, look at the phone systems, look at VX Prime. You'll read about it there. You can download the brochure, and you can look at the VX Prime video where I talk with Joe Talbot about some of the benefits of VX Prime and how it's going to make your calls sound great. Thanks a lot to Telos for sponsoring this part of This Week in Radio Tech. And check out the new Telos VX Prime phone system. I really believe in it. All right, we're with Mike Patton and Chris Tobin here talking about bringing transmitters back to life or keeping them alive for a while. So, Mike, you've done some work for us recently where you recommended some extra air conditioning. Totally agree with that. But tell me, what are some of the things that you find that station owners or station engineers aren't doing as well as they could that result in dead or short-life transmitters?
Well, the biggest problems that we see with transmitter sites are grounding, surge protection, cleanliness, and keeping the equipment cool. And I'll address each of those separately. Okay. Grounding is one of those things that is very poorly understood in this business, and that's a shame because it's important to every facility, transmitter or studio. In particular, transmitter sites, because, of course, we have this huge hundreds of foot tall lightning rod we've chosen to erect. It might as well be a sign on the top saying, lightning strike here.
Yeah, kind of like a mobile home in Mississippi. Hey, tornadoes, come here.
Yes, or in Florida.
Yeah, there you go.
But most engineers don't seem to have the grasp that I think they would be well served to have as to how ground systems, and certainly the EIA standards for towers are very minimal, like number 10-foot rods and things like that. It's like, I don't know who came up with that, but it wasn't anybody who was determined to have a site that's going to work after the storm passed.
Yeah.
We did for that site for your stations in Mississippi, Kirk, was we very carefully designed and contractor and it's ground system that in my professional experience is sufficient to the huge amount of current that it hits in a lightning strike into the ground and away. What I find works is a combination of vertical rods and buried connections between the rods and between the base of the tower and then the equipment itself, and that all interacts to provide a good system. The basic ideas are that you want to tie everything at the facility together so that whatever lightning potential comes in raises all potential. That's very key. Unitary ground is the phrase in the grounding industry. You don't want to have a low or high resistance connection between any 2 points in the facility, so that what you have, in that case, that could be very dangerous, because then you'll have lightning will hit for example, the antenna, and there'll be the equivalent of a resistor, even if it's a tenth of an ohm between the base of the tower and ground as an arbitrary concept. Well, 100,000 amps across a tenth of an ohm is still 10,000 volts. And a good-sized lightning strike can easily carry 100,000 amps to ground. So if you bring everything up together, then it's differential that kills you, as Tesla proved over 100 years ago with his Faraday cages. He would sit there as a demonstration in a 100 kilovolt electrified cage and be perfectly fine because he and everything else in the cage were all at the same potential. And the same thing applies for a transmitter site. You don't want to be there when it happens, but you're going to be safe as long as everything is well protected and well tied together. That's issue number one. And another corollary to that is that most people don't realize that AM transmitter ground systems that are good AM radiator ground systems are not automatically good safety ground systems.
Oh.
And so that's another issue. Another thing that's very poorly understood, and in fact, you sometimes have to fight the local electrical code inspectors to get this done, is that it's very important that the RF ground and the AC system ground be tied together and somewhere other than your transmitter, because the two are unavoidably connected in the transmitter. Because you've got a coax on one side and the power coming into the other side, and those two are necessarily connected in your transmitter.
Right.
And I will credit Clay Freinwald, I think I'm saying his name right, the veteran engineer for Intercom in Seattle, with coming up with the concept that I've used ever since. And he talks about the importance of having some sort of bypass around the transmitter between the RF ground and the AC ground, because if the only two places that those two systems connect is in your transmitter, it's the equivalent of staking your transmitter out in the middle of a 4-lane highway, where if you have a bypass around your town, you know, the sleepy little downtown goes back to being quiet because all the traffic goes around the bypass.
Yeah.
And I think that's a very useful concept for ground.
So let's talk about that for a second. How do you actually accomplish such a bypass? You know, I heard that engineers would sometimes try to get the electrical inspector to agree to tie the AC ground and the RF ground together, say at the service box, or maybe outside somewhere, just something like that. And certainly that might be best to do it even before it gets into the building, so to speak. But is there another way? Could you literally have a big honking wire outside the transmitter that goes around the transmitter? Would that do any good?
I suppose you could. What we normally do at a building is we put in a perimeter ground outside the building. We drive a ground rod at each corner of the building. Then we take the perimeter ground over to the tower, and then we run a few radial wires, bare copper, just a few inches below the ground, maybe out 20 or 30 feet. We drive a ground rod at the ends of those. And then wherever the power comes into the building, because the perimeter ground goes all the way around, we tie from the AC panel's neutral and safety ground both down to our perimeter. And we find that that's consistent, repeatable, and good enough. It might not be perfect, but the perfect is the enemy of the good, and it works. But I have had to literally disconnect the interconnect system for the inspector and wait till he left and then hook it back up.
Yeah. I think there's a pretty good drawing of what you just described that comes in the addendum at the back of Nautel transmitter manuals. Don't they provide a pretty good drawing of how to do this?
They do, and they've had that information available in their transmitter manuals for many years, and that's certainly a good guide, a good starting point. Very good recommendations there.
Yeah, what you want to try to avoid is your transmitter being the fuse between these two ground systems.
Yes, you don't want the equivalent of your transmitter staked out on an anthill.
Yes, exactly. Chris Tobin, in a city situation, you know, we're talking about buildings that are typically out in a field, and that's kind of what we have in rural America. But you've got tall buildings there in your part of the world. Can you give us some, rules of thumb? How are things done there with connecting AC ground and whatever you have for RF ground together?
Well, we have. I can tell you in two of the buildings I've worked in, we have a grounding system in the rooms themselves. They're all interconnected. It's part of the building ground, I guess you'll call it that. The AC grounds are properly insulated depending on which rooms you're in. You know, it's not like the buildings take direct hits, but they definitely get some corona discharge from lightning strokes that do fly around. You do your best. You know, pretty much if you're connected to the building frame, in many cases that's how I've seen it done. There are several different ways you can do it. As long as Mike points out, you create a very low resistance, that is, the best you can. The building I was in the other day, the cellular folks who were putting these indoor antenna systems in, it was interesting the way they were bonding their copper grounds and using what do they call that again? And I can't think of the name, that weld that you use. And it was just fascinating.
CAD weld, yeah.
Thank you. Yes, the CAD weld. To the I-beams, to the superstructure of the building. They actually cut a hole in the sheetrock and had a blueprint as to where they can connect it. And they said this worked. And they had the mega ohm meter and they're measuring and checking everything out. And it was like, oh, because for them, it's not only grounding is important for the protection purposes, but it's also to minimize noise in their receivers and noise that comes from the transmitters. Because they're talking about receiving signals at around minus 130 dBm or close to 150. So it's a combination of both protection and systems efficiency for reception.
Yeah, CAD weld is considered the king of it because it's literally a copper oxide that you fire off with a mold, you burn it, and there are no dissimilar metal issues. You got copper to copper with copper, and so you don't have to worry about any of those dissimilar metal indices or any of that stuff you learned in metallurgy if you learned it. The second tier down is silver solder. That's mostly what we do. Some of the electrical contractors we work with have the molds and such for CAD weld. And CAD welding is fun. It's like legalized fireworks. I get to light stuff up and blow it off. But silver solder works very well for us. It's physically very stiff and very tough. It doesn't oxidize like soft solder. It'll still be there 50 years from now. And because it's 15% silver, it's phosphor bronze with 15% silver, and those metals work with the copper very well. It's a low cathodic index, I believe is the correct term. And again, it's a very good connection. And then soft solder, I would never do any soft solder outside. It just does not hold up. You dig it up 10, 20 years later, you can pull it apart with your hands. And the worst, of course, is a clamped connection. I hate to see anything that's just held on mechanically. That's never a good idea for grounding. Because on a microscopic level, it doesn't make a good connection.
Yeah.
And that's what matters. It doesn't matter what it looks like to us. It matters what it looks like molecule to molecule.
Yeah. Yeah. Wow. I always wanted to do CAD welding and never got the tools to do it. So, Mike, let's say you've got an engineer as a project. He knows he needs really good, something good here. Again, what technology, what can he do himself, or what does he need to hire somebody who does CAD welding to do?
Well, the CAD welding molds are not expensive. They're not cheap either. And every different type of interconnect has to have a different mold. Yeah. They have molds that do strap to ground rods, and they have molds that do 2-aught to ground rods. And so you have to have this huge library of molds. Unless you do the same thing over and over again. And that's expensive. We don't do any CAD welding ourselves. We sub all the CAD welding out if we're required to spec CAD welding. But silver solder is easy. You can go down to any welding supply place and buy 15% silver by the pound or by the stick sometimes. And these MAP gas torches will get strap hot enough. They'll get ground rods hot enough.
Okay.
We've got to do something like weld to a tower, but a little oxyacetylene rig, you can buy it at Sears for $300, and you can get the bottles. They're called pony bottles at any welding supply place, or even like Fastenal or Air Gas or things like that, and they're about $50 a pop for exchange. They're not bad, or even less, and you can heat anything as hot as you want with one of those.
And are there? If you're trying to do silver soldering, and I've done some of this, and I only did it with copper strap. I don't think I ever tried to silver solder to bigger items like a ground rod, or I didn't want to touch a tower. I thought I might, ruin the integrity of the metal of the tower. That's a good question. What should an amateur like myself stay away from and not try to silver solder himself?
Well, if you're going to silver solder to a tower, you have to be very careful about two things. One is where on the tower you connect it to, so you don't heat it up and it falls over while you're underneath it.
Yeah.
So, many tower plates, or they have some minor structural member that if it gets hot, it's not a big deal. I would be very, very reticent to attempt to heat up hot enough to flow solder to the actual support leg itself on a tower. I would not do that.
What about tabs? Some towers have tabs.
Well, that would be the obvious easy thing, because that's what they're there for, and they're designed often to cadwell to or to even bolt to, and that's very, very safe. The other thing is essentially all galvanized, and you have to be very, very careful when you heat up galvanized steel, because as I understand it, and I'm not going to say the name of the gas because I'm probably going to say it wrong, but there's some very poisonous gas that can be released when you heat up galvanized steel hot enough to silver solder to it. You have to take the zinc oxide off before you can wet it with the silver solder. So what we do is we take a wire wheel on a drill and we grind it off down to bare steel, and then we silver solder to it, and then we buy cold galvanized and spray it back on it, and that's the end of the process. But it works. You just have to be very, very careful.
Cool. Okay, good, understood. Chris, anything different or the same from your perspective?
No. I mean, I've had the chance of watching folks do the CAD welding. It's a pretty wild experience. I have not done it myself personally. I've been an observer. Silver soldering, yes, I've done that over the years. No, Mike's right. Mike's got it right and spot on. And I've heard about the gas with the zinc, the galvanizing. That is true. I've worked with a couple of tow crews that they were doing somebody was doing some burning, and one of the guys stopped them and said, "Did you clean the galvanizing?" And when the guy looked at him perplexed, the job came to a halt, and things got taken care of. So there's lots of truth to that.
So Mike, you mentioned three things that are particularly troublesome at transmitter sites that cause shorter transmitter life: grounding. Then you mentioned cleanliness, and finally cooling. Talk about cleanliness, and so many transmitter sites are just so nasty, and yet others are well kept.
They are.
Tell me about the differences there.
Well, in my opinion, cooling and cleanliness go together. That if you have a transmitter site that is either unair conditioned or that has a conventional, I say conventional, a very common system where the transmitter's exhaust is ducted overboard, and there's an air conditioner that simply cools the room, whether it's a window air conditioner, which I hate, or even a small conventional split system, and then there's essentially no provision for makeup air. And it's like, if you're exhausting air overboard, it has to come back somewhere. You're not pulling a vacuum in your room. There is air there to breathe. So what happens is that air comes in every crack. It comes in around the door. It comes in every nook and cranny in the building, and it's not filtered. And because in the country, and this includes your Mississippi stations, Kirk, most transmitter sites are in rural areas and often out in the middle of a plowed field. Most of us aren't farmers. I'm not either, but my father was, and I grew up on and off a farm. And let me tell you what, unless it just rained, when you're in a plowed field with a disker going, there's a ton of dust in the air. And that dust gets sucked right into your building and ends up on your tube cooling fins and ends up coating your high voltage wire and ends up everywhere. And this is bad. This is very bad for a transmitter. There was a station a couple of years ago that asked me to come in and look at their facility, and it wasn't too far from the site there in the Delta. And they had no air conditioner. They had an exhaust vent on the transmitter that was just unpowered. It was letting the transmitter push its air outside, and it was in the middle of a plowed field, and the place was a mess. There was a quarter-inch of ugly, gooey, oily dust over every single thing in the entire building. And another issue with that is that most have enough blower capacity to overcome some long duct. People don't realize that the back pressure on a duct is part of that is how long the duct is. How for a given length of a given length of duct, it has to be bigger and bigger to keep from having too much back pressure. Anybody who's ever built a hot rod knows this. You put on a header and a bigger tailpipe and get more horsepower out of your engine.
Yeah.
Well, it's the problem with the transmitter.
Same thing.
Right. The transmitter's blower is spec'd as just big enough to push air out the top of it, and that's about it.
Yeah.
And, if you have a 4-inch vent that someone connects to a 10-foot length of 4-inch flexible dryer hose, newsflash, that's not going to work very well. And that's something that's poorly understood about airflow by most people. We're gonna be
short of time here in a minute, but Mike, I want to cover one extra little topic because for years, back when we were really in the tube transmitter days, I did advocate positive pressure, unair conditioned transmitter sites at some locations where you'd blow air in at a low velocity but a high volume through the best air filters you could get. And then, your transmitter would have a fairly easy time because it was positively pressurized, blowing hot air back out. And I advocated that in a few situations, but you alerted me to a factor that I was forgetting in that situation. And that is this something that I've discovered in my weather training, and that is latent heat. Because the air outside, especially in the southern part of the U.S., is moisture-laden, and that moisture, those water vapor particles, molecules have latent heat because they're moist. There's water, and the water's warm, and you bring that into a building, especially if you're trying to then cool it. You've got a real energy problem there. You're going to burn up a lot of electricity and energy. You're not cooling dry air. You're cooling wet air, and that makes a huge difference. And you showed me through examples and mathematically how it's just a dumb idea to try to bring outside air in and cool it and then ship it back out the transmitter. You're much better off, or you're just about as better off with a closed system. Talk about that for a minute.
Well, I had the great advantage of having a drinking buddy in college who was an air conditioning engineer. And he and I are still friends. He lives in Memphis, and he's a great guy. And he taught me, we sat down many, many years ago, 30 years ago, with one of the very early computer modeling programs. And we literally stuffed all the different numbers into it for this humidity and this location and this amount of airflow versus the 140-degree dry air out of a transmitter. And actually, I was somewhat surprised to see that by the time you factor in having to remove the humidity in this part of the world, you're only actually having to put about 10% more capacity into having an entirely closed system and simply cooling the closed air and not venting the transmitter outside at all, versus having an open system where the transmitter dumps overboard and you have to suck in the makeup air and take the latent heat out of it first before you can take what's called the sensible heat out of it, the actual temperature down. Now, if you're in Arizona or the Atacama Desert, the driest place on earth in Chile, those equations are a little bit different. Yeah. But I don't live there. I live in Mississippi and Louisiana and Florida, and that's where I do my work. And here, it only makes sense to make it a closed system. You have a little bit of penalty, 10 to 15%, but you have all the advantages of a closed system. You have a clean transmitter, you have a clean site, you don't have to worry about changing filters, and you don't have to worry about positive pressure in the building. You get rid of all of that complexity.
Wow, good points. Good points all the way around. And we're gonna, we kind of covered cooling there with the benefit of cooling a closed system. It doesn't cost either the same or not much more than trying to cool outside air coming in, and that's a great point. If you're in a humid environment, which most are, a good part of the U.S. certainly is. Guys, we got to take a break here and come back with a tip. If you can afford me a tip when we come back, our show This Week in Radio Tech is brought to you in part by the folks at Axia. And yeah, I work for the folks at Axia, so I'm pretty familiar with what they do. And one of the things that I've really become familiar with is this notion of an additional standard. We've had LiveWire. The folks at Axia had developed and actually have a couple of patents on some timing features of LiveWire. And that goes back 15 years now. But now there's a standard called AES 67. And this allows different manufacturers with their own AOIP networks and all the conveniences that they may build into those it lets them talk to each other. Now, the idea here isn't to build quite a hodgepodge studio of, half your equipment is this and half your equipment is that and just use AES-67 to tie it all together. You could do that, but we at Axia, we really see benefit in saying, well, choose one AOIP system to tie most of your stuff together. But if you've got a few, I don't know, I wouldn't say oddball, but if you've got a few pieces of gear that don't speak Livewire or don't speak whatever system you choose, use AES-67 to talk to those. So maybe you've got a power amplifier, and I know there's some coming out on the market that have AES-67. There's already speakers. Genelec makes speakers now with AES-67. Neumann makes a microphone, and you don't plug in the microphone itself. There's a rack mount box that does all kinds of other stuff for the microphone, but that has AES-67 built in. And you're going to see more products with AES-67 built in. That way, a manufacturer that makes just a single product or a small line of products, they don't have to build in different standards like Dante and AVB and Livewire and others. They can just put AES-67 in that product and let any of those others talk to it with AES-67. Well, that's built into Axia's Livewire. We call it something new. We call it Livewire Plus. Well, that's an easy marketing thing to add, but the plus simply means we've added AES-67 to Livewire. Now, unlike, we could have done this in a tough way, but we made it really easy. With Livewire Plus, AES-67 is simply one more stream type that's available. So in a Livewire system, when you're choosing, do I want a live stream? That's a very low latency stream with a very high packet rate. Do I want a standard stream that has a higher latency but a more normal packet rate? Do I want a medium stream, or do I even want a surround sound stream? One more choice there, and that is, do I want an AES-67 stream? That way, a lot of the benefits of Livewire still remain, and like GPIO to everything else, discovery of things everywhere else. But if you need to choose AES-67, you just click on it. Now you're either generating or you're receiving an AES-67 stream, and it's just as easy as it could be made. So now you get that connection to other devices. The AES-67 standard has now been around for over 2 years. It was ratified in September of 2013, and Axia, I believe, was ready from day one with a product, the X node, that already had AES-67 built into it right away. The first U.S. product certainly to have that built in. And now there's something additional. Manufacturers have come together in the Media Networking Alliance. That's a group that Telos is proud to be part of, Axia, the whole Telos Alliance, actually. And so it's a group of manufacturers working together to make sure that AES-67 is promoted and is talked about, and that you as engineers know about it and can easily learn how to use it when you need to. I'm really delighted and proud to be part of the Telos Alliance and to see Telos's commitment. Of course, Telos is committed to making Livewire as good as it can possibly be, but they're also committed to making sure that you, the end user, we engineers in the field, that we get to use these new technologies just as soon as they become available and become commonplace. So that's what Telos, and that's what the Telos Alliance's commitment is, to being able to work with other stuff. Even though Telos, Axia, Livewire already had more partners and more pieces of equipment than anybody else out there that were already worked with Livewire, we added AES-67 to make sure it was available right away. Now AES-67 is built in to our console line, the Power Station, and also into the smaller consoles with the Core 16 and the Core 32. So it's important to us, and we think it'll help you out a lot. Thanks a lot to the Telos Alliance for sponsoring this part of This Week in Radio Tech, and thanks to Livewire Plus. All right, hey, I got a quick tip that I'm going to pass along. Guys, if you'll be ready to pass yours along. We were talking about Lightning, and I love this app. That's both a website and an app. I use it on my Android phone. I assume it's available for iOS as well. And that is these apps that show you where Lightning is in almost real time, like maybe 5 or 6 seconds behind real time. And one of the easiest websites to remember is lightningmaps.org, lightningmaps.org. And you can see a real-time display of lightning in your area, all over, actually anywhere in the world. There's another website. I don't know how to pronounce it. It's looks like it's pronounced blitzortung.org. believe it's a German website. There's, of course, an English page. In fact, I go to EN, I guess that's for English, en.blitzortung.org, and they have a live dynamics map page. They have several different versions here, but you can even have it show where the lightning sensors are and what they're picking up. And they triangulate fabulously to show you active lightning strikes. There's some in Tennessee right now. There's some in southern Mississippi. Right in the middle of Alabama around Birmingham and Tuscaloosa, they're getting lightning right now. Down in Louisiana, I see some that's maybe not too far from your location, Mike Patton. You're getting lightning there. And let's look up in the New York City area. Let's see here. Oh my goodness!
Sure, it's out at Long Island, out east toward Massachusetts, Connecticut, that way. No.
Yeah, let me zoom in here and have a look. It just takes a moment for my computer to. Oh yeah, Long Island is the western half of Long Island is covered up right now. The worst of it though is just southwest of Hartford, Connecticut. That's where the most active lightning is. I guess that has moved up to the northeast.
That's what came across New York City earlier around 4:30. Yeah.
You also get history, so the lightning indicators change color to show you, okay, hey, 45 minutes ago we had lightning here, but now the active lightning is, here or there, wherever it may be. So cool. I'll put it in the show notes, lightningmaps.org or blitzortung.org. All right, Chris Tobin, have you got a tip you'd like to pass along to us this week?
Well, recently did a project where I had to develop an emergency action plan, and it made me think about this. How many times I've been at radio transmitter sites where there's no information as to what the site's about, and I'll explain. One of the sites I have, when you walk into the room, on the wall, very clearly posted, I've got a sign that says, "This room is number X on this floor." And this is the contact information in order of where you want people to call. And it also has the building engineer's name, the assistant building engineer's name, the building manager, and everything else, and other numbers that are important to the room. And I realize that a lot of times people don't think of this because when everything is calm and normal, why would you? But when when panic strikes, then it's all of a sudden like, well, what number's there? Who calls what? How do you do this? Make sure that numbers for your air conditioning services are the night numbers as well as the daytime. Don't leave just the daytime number. Make sure you have a night service number because not everybody has one number for both. Also, if you're talking, for evacuation, say studios, studio offices, make it clear that the information is very poignant. Don't try to cram everything into one 8.5 by 11 sheet of paper. Think of it in terms of if you're running out of the building and somebody's asking you 6 questions, can you read it from this piece of paper? If you can, then you got it right. So the idea is to be prepared for that. So this time of year, craziness is happening with the weather. Today is an example. I would say rethink how you're protecting a site. Think of it this way too. I worked at a radio station many years ago where we had an issue where the fire department was called, and our transmitter site was a big brick building. I mean, literally just a brick building with a nice 500-foot tower next to it. And I had posted signs on the outside of the building with important numbers as well as high voltage inside. Use water carefully. Fire department was grateful because when they showed up, they were about to start banging away at the doors, and on the other side of the door was the service coming into the building, the 400-amp service. So, these are the kinds of things you got to think about, and then step back and look at your situation and say, have you posted this information? Make the assumption, what if I'm not here and something goes wrong? How would somebody get through, the situation? So that's my tip: is emergency planning.
Good advice. Let's Chris, let's converse about that so I can know how to put that into the show notes when I write those up. And real quick, we just got a minute. Mike, you got a tip for our viewers and listeners?
Stay away from the ponies. No, seriously. I second what Chris said about emergency contact information. What we've done for years at transmitter sites is post the just kind of an emergency checklist, obviously 911, but the actual non-911 number for the local fire department, the local whoever has authority, the police department, the sheriff's department, whatever the local law enforcement office is, account numbers for the power company and their contact information, the emergency contact information for the air conditioner contractor, as Chris said, maybe the guy who cuts the grass that has contact information. account numbers for the phone company and the SPID numbers for the ISDNs if they had ISDNs, login credentials, whatever they want. So, because these days, if you call AT&T or someone, you say, "Hi, I'm so-and-so from somewhere." If you don't have the right PIN number or whatever the password is, they don't talk to you.
Yeah.
And so, that's important because it's not always going to be me there. I've got several people who work with us. We don't do much contract information work anymore, but when we do, we don't want to look like a bunch of yahoos. We're going after a site. We want to have our stuff together. And last but not least, we put the number of the local pizza delivery place in case we're stuck out there in the evening.
Nice.
Pizza and Chinese. Well, whoever delivers. That's a great idea. Great idea.
One thing to add. One thing to add. I just totally forgot. Remember, now that we're in the world of IP telephony, a lot of our transmitter sites have extensions from our offices. So corporate phone numbers, the corporate telephone, I call it telco WAN, is at the site. So if you're doing 911, remember, it's 9911.
Oh.
Dial 9 first.
I've just read a couple of telecom reports that there's a push to make some changes in the telecom world about that. So,
and if your phone at the transmitter was an extension off the corporate business system, they wouldn't necessarily know your address, would they?
No, that's why you have the information on the wall. I'm in building X. I'm located between these streets on this street. This is what it's about, and that's why you do that.
Perfect. Makes perfect sense. Thanks a lot. Guys, we got to go. We got to get out of here. We're out of time. Mike Patton from Michael Patton and Associates has been our guest. He's got a website. Michael, what is that?
MichaelPatton.com. Couldn't be simpler.
That's easy. All right. And he repairs equipment in his office. If you got, you can ship him stuff. Talk to him first. Get a price. Beat him up on it. That kind of stuff.
Oh, thanks, Kurt.
And Chris Tobin from the New York City area, an expert in IP everything, as well as studios and transmitters. Thanks, Chris, for being with us. We sure appreciate you.
Oh, you're welcome. Well, I could say I was on Wi-Fi today. I'm on battery on my MacBook. I'm totally wireless, literally everything. And even my microphone is a USB microphone. So it went very well. I still have 35% of battery. It's nice.
How does that work so well? That's just amazing.
Planning. That's what I'm trying to tell everybody. Planning. You just don't assume anything. Plan.
You plan more than anybody I know, and it seems to pay off.
Well, I was planning to be in the park today because I thought the weather was going to be nice, and suddenly a cloud came by. So I had a plan B.
Yeah, and lightning, too.
Yeah.
Hey, thanks very much to Suncast for switching and producing our show today. We appreciate that very much. Next week, Richard Hickey is our guest. You don't know who he is probably, but you will by the end of the show. And you're going to find out some cool things about towers, regulations, lightings, and what to do when things go horribly, horribly wrong. Richard will give us the lowdown and things that you need to make note of with towers and tower crews and lighting and RF and all that stuff. That's coming up next week. Thanks to our sponsors. We appreciate it. And again, to Suncast and Andrew Zarian, the founder of the GFQ Network. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.